Welcome, everyone, and thank you for joining us today for our webinar, The Future of Efficient Buildings, Technology's Role in Driving Sustainability and Performance. My name is Ava Montini. I am the Senior Marketing Manager at Blade Air. We focus on advancing indoor air quality technology and efficient building solutions. And I'm really thrilled to be your host today for this discussion on really how smarter and more sustainable building strategies are shaping the future of commercial real estate. Buildings account for nearly 40% of global energy consumption and over 1/3 of greenhouse gas emissions, making them one of the most critical areas for impact when it comes to sustainability, efficiency, and cost reduction. And at the same time, poor indoor air quality costs the US economy an estimated $168 billion annually due to lost productivity and also healthcare expenses. So we have rising costs, stricter sustainability requirements, and evolving IAQ regulations that are demanding for smarter, more efficient solutions. But the rush to comply has forced many businesses to make costly HVAC retrofits. Oftentimes, they're installing oversized systems or increasing ventilation rates unnecessarily. This can lead to sometimes overventilation, higher energy costs, and still fail to resolve underlying air quality challenges. But without a targeted approach, these efforts risk creating inefficiencies rather than solving them. This webinar today is going to cut through all of that noise and focus on real, actionable solutions. Today, our panel of experts will explore the latest advancements in energy-efficient building technologies and smart ventilation strategies that optimize performance without overburdening your systems. Because really the future of building efficiency isn't always about doing more, but it's about doing smarter. We have a powerhouse panel today of experts that I'm really excited to introduce you to, and they're all going to be sharing a unique perspective on optimizing building performance. So firstly, we're going to be having Charlie Holt, the CEO of Keynotion, and he's going to be providing insights into innovative energy efficient projects and how businesses can embrace sustainable solutions across building systems and portfolios. We will then have EC, Caley, the co-CEO of Poppy, and she's going to be introducing the role of clean air intelligence and real-time data in driving energy savings, decarbonization, and occupant health. And then lastly, we're going to be hearing from Jake Esselman, the account manager that we have with us today from Trane Upper Midwest, and he's going to be diving into ventilation and filtration strategies that optimize energy use while also ensuring compliance with sustainability standards. So to kick things off, let's take a step back and start looking a little bit at the bigger picture. What does energy efficiency really mean in the built environment today, and how businesses can ensure that they're making the right choices when it comes to sustainable upgrades? So we're going to have Charlie, who's spent years helping organizations navigate the intersection of IAQ, energy efficiency overall, and project development. And he's going to be walking us through smarter, more efficient strategies, reshaping building systems for the better. So Charlie, it's over to you.
I'm Charlie Holt, and I'm with Keynotion. And our strategy is around we help buildings reduce costs and improve profitability through smart IAQ. We do some other things, but this is really our passion and our focus up front is how do we deliver a more sustainable indoor air quality standard within our buildings. So our commitment, as we look at it, my wife Kelly and I own the business, and so as we look at how do we help our clients, we always look for innovative technologies. So how do we kind of look into the future of how we're going to do projects, technologies that are going to be around for the long term, and in a lot of cases, a lot of the emerging technologies come with a lower cost of operation. We look at the human side of it as well. So prioritizing indoor quality and environmental quality is another one of our core values into it. And then we want to be good stewards of the environment. So how can we be more sustainable, reduce energy, reducing our carbon footprint along the way? So we work with a lot of different partners. And today, as you look at the screen of all the different ones we work with, and again, our host for Blade Air and EC and Poppy and Trane. We have partners that we fill different roles across the portfolio. Our newest one you'll see there is Bay, and we're leveraging better indoor quality across the tribal nations now and helping them improve their environments as well. But today is kind of really around, from a project development standpoint, how do we help clients, whether it be building owners or contractors and partners, navigate that indoor quality. A lot of where we start with is around our project development. Again, bringing people together to go ahead and talk about healthier buildings and strategies and how we make assessments and improvements. We target doing the initial assessment along the way in our process. And then we look at our filter standards and indoor quality as a general from a global standpoint. In many cases, we look at the reduce before you produce model. When we're looking at buildings, if we can reduce our energy consumption within the building, it allows us to look at other things like solar and other technologies to support our community and our initiatives for carbon footprint reduction. Why do we start with them? It's really around, three easy things. Is a lot of cases, because we're not putting in brand new infrastructure and all that, it's a cost-effective approach to being able to make improvements to the building. And in a lot of cases, as soon as we make the changes and we implement strategies and technologies, we see immediate benefits. It can be a quick turnaround and an easy way to see the benefits from day one. And if we're reducing the load on the systems and making things work better, we can potentially impact the useful life of the equipment and extend that as well. So when we look at developing projects into this space, and everybody has those challenges as well, we look at the fact that in many cases, before we even start, there's a lack of budget for being able to do assessments in that. A lot of cases to do building modeling and other strategies into the world of it. So we have to take more of a lean approach to how we develop these things. In a lot of cases, we end up with incomplete data, the lack of building plans, historical records of how things have been operating. And a lot of times the equipment is beyond useful life and there's not much information about them. And then as a development team, you look at the people on the call here today, it's constrained resources. So there's all of us are out there putting our hands in and pitching in to get things done. And so I think our approach allows us to do better with the constrained resources as well. So looking at a team approach. So when we look at it, and examples of the people on the panel here today with EC and the technology that Poppy brings into the world of it, seasoned project development professionals, whether it be equipment people, engineers, or people like myself to help quarterback the process. And then we have the system specialist. So when we're bringing everything together, we want to make sure we have a positive impact on the system, and having everybody in the conversation is beneficial to every project. So improving indoor quality isn't just a challenge. We look at it as an opportunity. A lot of cases, again, like Ava mentioned in the beginning, there was a big push to increase fans and doing all that kind of stuff. I think our strategy around indoor quality makes it more of an opportunity. The strategies we can come in with help us reduce energy and operating costs up front. We can still align with compliance and sustainability measures, whether it be ASHRAE 241 and carbon reduction goals. And in the end, the byproduct is we create buildings that are safer and healthier for people to come into. So we look at the ASHRAE assessments, and down on the bottom of the slide, you can see it's one of the things we talk about every day. You can't manage what you don't measure. So coming into the ASHRAE assessments, we see that a data-driven approach up front, whether it be a single zone testing or a whole building testing, being able to have that data up front is very key to our success in really framing up what is happening in the building and how we can make those improvements. We can also look at, with that ASHRAE 241, how do we align with compliance? How are we looking at risk reduction, whether it be buildingness ready plans or other strategies? And again, with the amount of savings that we're finding, we're identifying, we're being more sustainable and we're helping reduce the overall cost of operating the building. So once we get our assessment done, we can start looking at things like our filter strategy and specification. So based upon the need of the building, whether it be healthcare, schools, office, industrial, we can evaluate that filter specification and make sure that we're maintaining the environment as it's being used. A lot of cases we repurpose buildings and maybe those strategies and equipments have not been updated in order to align with that. So when we look at our low pressure filter strategy, it kind of covers a lot of things. We're able to get energy savings with it. We can check the box of increased indoor air quality and reducing and those costs with that. And also sustainability. When we can reduce our carbon footprint and check the boxes of scope 1, 2, 3 emission reductions, we're doing better of throwing away less stuff into the landfills. So our equipment, our system specialists are key. So we can go in and identify what we could potentially do in the building. We got the tools to go ahead and capture that data. But I think what's really key is we need the people who are system specialists and have them help us maintain as well. If we're adjusting fan horsepower, is there a need that we can ramp up fans, slow fans down? Do we need to adjust cooling? There's a lot of other considerations other than just the ventilation. And having an HVAC system specialist really helps us keep the whole project on target. I'm asked, when do we plan on indoor quality? When should we assess it? I like the proactive approach versus the reactive. If you're looking at adding onto your building, making changes to the ventilation system, building a new building, that's the prime time to be able to go in and say, what are my requirements for indoor quality? How does my space maintain it? And that can help you in decisions around what kind of systems and equipment you have. Again, it's allowing us to optimize the energy usage and having those indoor quality strategies to be able to make a high performance system. And then the long-term ROI. When, again, we're reducing our energy, we can leverage renewable energy to go with it. We create a long-term ROI for the building and bring more value within the assets.
Perfect. Thank you so much, Charlie. Really appreciate that. It was a great look at how organizations can really rethink how to approach energy efficient upgrades, especially focusing on IAQ. One of the biggest gaps in building performance today is often the lack of real-time visibility into air quality, though, when we are getting ready to make these investments. And many buildings will end up overventilating, as I mentioned earlier, and Charlie alluded to, because they actually don't have the data to optimize their systems effectively, which can lead to higher wasted energy and higher costs. So our next speaker today, EC from Poppy, is going to be really diving us into that. And their company is essentially leading the change in clean air intelligence technology, really helping organizations understand their air quality in real time, enabling data-driven decisions, and improving health and energy efficiency overall.
It's an absolute pleasure to be spending some time with Charlie and Jake talking about one of the topics that I'm incredibly passionate about, and I'll admit it, really nerdy about, which is how do we make the world's most efficient buildings in a very easy, very approachable way. What we do at Poppy is we help energy optimization while maintaining healthy buildings. So you can find us at poppy.com. And what I particularly liked about the topic that was queued up for today, and thank you all for joining us, is a specific type of technology that I would love to highlight, which is particle tracer technology, which might be a little less familiar to some of you on the call, but really over the last 3 to 5 years has come into its own, and especially a real-time version of it. At Poppy, we've done more real-time particle tracer testing than any other organization in the world, and I'm really excited to share some of those results with her, some of the learnings that are now being used to make a really big difference in efficient buildings. But first, just by way of quick introduction, Sam and I co-lead the company. We've been working together for 10 years. We used to, Sam founded Meta, a company you may have talked about or you may have heard of before. But we really wanted to come to this industry and help buildings use technology, a combination of hardware, software, artificial intelligence, an Internet of Things, in order to be more efficient and enable like really, really incredibly healthy spaces. So during the pandemic, what we ended up doing was measuring, entire cities worths of buildings, and really focusing on equivalent clean air and clean air flow. And we continue to develop and create breakthroughs that now are being widely adopted within the industry. And we've been honored to participate in helping set ways in ASHRAE 241, for example. If you look at Appendix C, aerosol particle tracing methodology, making it really easy for people to both understand and implement these sort of measurement technologies so that they have that roadmap, to use Charlie's phrase, measure so you know what you can do. I just wanted to highlight on our team just one individual, Dr. Marwa Zatari, who's our chief engineer. She is very well known and well respected in the industry, one of the smartest people I've ever met. She's the vice chair of ASHRAE 62.1. He played a huge role in ASHRAE 241 as well, on the board for the organization that is responsible for the LEED categorization of buildings. She knows her stuff, and she's just one example of the type of passionate and incredible people on our team we're honored to lead. But to sum it all up, we're data nerds, and what we're trying to do is make it really easy to get actionable data in the hands of people who run buildings, so that with very little cost and very little difficulty, they can actually make their buildings more efficient. And I'm not going to go into the problem very well. Charlie definitely gave us a good highlight, as well as Ava. About 50% of what any building is spending money on is heating, cooling, and circulating air in a building. And that's obviously incredibly expensive. And what our data has shown, if you want to take a look at the ASHRAE Journal article published last September, for example, is we've done one of the largest building surveys and found over and over and over again so many classes of buildings that were wildly overventilating compared to the occupancy of that building at the time, or in regular sort of everyday usage. And that's really one of the opportunities that has been driving our business and the field of particle tracers forward. So we'll talk about some of the specifics there. But it's really about optimizing ventilation, helping buildings decarbonize, and reducing the energy spent in HVAC. And absolutely, our bottom line, one of the things that drives everything we do, while making sure that the building is incredibly safe for occupants. Why is this possible now? Why is this technology really coming to the forefront? Many of you might be familiar with basically using gas tracing within buildings. That's something that's been around in the industry for many decades now. The challenge is partially it's expensive and fairly cumbersome to do. Real-time air tracing technology, think of it as a fit test for a building. So we're basically challenging the building with really salt particles that get diffused into the air, and then measuring how well the building systems recover from that assault on the system, while maintaining the building fully occupied, no disruption to the way the buildings are operated. Both an installed version, but we more often do the portable version, where come in, create these measurements, and then basically use those to put together the optimization plan for that building. And if there's buildings, for example, many schools or those sorts of buildings, there might be many places where they need to improve and add more clean air, both to comply with something like 241, but just generally for the well-being of the occupants. But often in many classes of buildings, we're finding all the data is showing how over ventilated, both dilution, filtration, or some combination of those. Many of those places are, again, especially compared to occupancy at the time. So in the middle here, you'll see just some examples of the 3D renderings that we can do based on this data. There's an advanced version where we can understand directionality and really complex flows. And really having the standards come through and validate and support these types of methodologies has been something that has made a big difference in the adoption. So again, I encourage you to take a look at the ASHRAE article. More widely speaking, where we find in Class A, Class B buildings, especially office, retail, public venues, the clean airflow per person rate, as dictated by 241, is 2.5 times higher on average. And you can sort of see it's not exactly a bell curve here, but it sometimes can be much, much higher. There's the ability to be able to bring that down, save the money on heating, cooling, and circulation, but while maintaining a very safe building for the occupants. And that's really through a simple recommissioning process. I mentioned being able to do this with portable technology, basically sensors and a nebulizer like the one you see here in the second image, following the protocol set out in ASHRAE standard of measuring a good sample of the building in order to get a good representative view of how the building's performing in that fit test. And then basically technology, our systems like ours, we do all the calculations. Everything's automatically done in the background in real time. So before you literally finish that test and move on to the next area on that same floor in that building, you know exactly how well that area is performing. And that leads to then the optimization step, which is not about any kind of new capital expenditures. Typically, it's really about adjusting some of the settings in your existing modern HVAC system, and then monitoring that on an ongoing basis to make sure that energy is continuing to be saved wherever possible. And one of the things that we've been able to introduce is when identifying potential high energy savings buildings, which we'll talk about a little bit later, we're now introducing what I'm hoping is the simplest ESCO model anybody's ever heard of, or anybody ever is going to complete, but really something where we get to share the savings with the building owners and the tenants, 50-50 of all of the energy savings in year one, and 75% of the energy savings and the energy reduction costs to the owner and tenants, depending on how the building's metered in year 2 and beyond, while all the time guaranteeing that there will be a positive ROI on all the work. And then in other types of buildings, buildings that, again, I mentioned typically what we find in older schools, for example, we have a slightly different model, but it really helps at really pennies per square foot for buildings to be able to get the data and validate the improvements that have been made in the buildings in order to make sure that they're having the safest and healthiest building they can. So one of the questions we typically get is just what buildings are good candidates, especially for that first part of the model. Where do you find the biggest energy savings? And now, after doing 13 to 15,000 of these tests and all over the planet, we definitely see that Class A, Class B buildings, really regardless of what modern mechanical systems are in place, so whether that's DOAS or DCV or anything else, office, retail, and public venues are almost always, energy savers and potential energy savers, and up to the hundreds of thousands and even millions of dollars, depending on how big those buildings are. And so it really is a complement, a way without making another capital investiture to be able to optimize even when you've already invested in the building with maybe some of these systems. And the nice thing is it all lines up to a lot of the building certifications that we all love to have on our buildings. Essentially, the ability to get points towards your next round of your LEED or GRESB or even things like Wired Score. Here's a little bit of an eye chart, but just wanted to give you an idea of sort of a range of like the types of energy savings. So if you take a look at the line just a little bit down here, like how many equivalent acres of US forest have been saved in buildings, again, sort of depending on their type, depending on the climate zone, depending on their size, depending on what our tests have shown. Sort of starting at this end of the scale, we were doing a courthouse, a set of buildings in the justice system where there was zero energy savings expected. Older building, older systems, and definitely found areas that needed improvement, like more equivalent clean air, but found enough spaces where they actually could make adjustments based on our data, where they could basically make the cost of the project net neutral, which was a very, very happy surprise for everyone. And then schools, again, depending on the building and how new they are, typically are more, lower ROI on energy savings. savings for sure, but definitely the ability to be able to, get the stamp of approval and making sure that based on occupancy, you're covered in flu season and COVID and everything else. And then office buildings, a couple of different climate zones covered here. Lots of savings, especially per square foot, that are available. And this is really just the tip of the iceberg. Lots of different techniques and methodologies that we can propose based on the data that we find after we've done the first measurement on a building.
Thank you so much, EC. It's definitely really clear that the access to real-time data that you and Poppy are exploring is a real game changer. For sure. And making informed decisions about IAQ and energy efficiency is really necessary by having that real-time data. So we thank you for that. But also with that, there is a need for ventilation and filtration strategies to ensure that buildings are running at peak performance once you have that data. So that's why our next speaker, Jake from Train, is going to be coming in and telling us a little bit more about what he does every single day to optimize HVAC systems, to reduce energy waste with his clients, and overall improve air quality without overburdening mechanical infrastructure that's already in place. So he's going to be sharing some best practices for smarter ventilation and filtration that are driving real results. So with that, Jake, you can take it away.
Thanks, Ava, and thanks everybody for joining on the call today. Do a quick introduction here. Jake Esselman, I'm an owner direct account manager with Train. Been with Train about 12 years. I had 3 years at Johnson Controls before that. All of my time really has been in the HVAC industry with the owner direct, in the owner direct space, working with facility managers and building owners, healthcare, K through 12, industrial vertical markets. I have a lot of experience in preventive maintenance and turnkey projects that are focused around sustainability and maximizing processes or comfort cooling. Ultimately, my goal is to understand how we help leverage our clients' buildings and systems and operations to meet the needs of their businesses. Traditionally, when we think about Train, our heads probably immediately go to all the great equipment that's out there, from air handlers, chillers, heat pumps, really a full breadth of equipment. But I want to take a step back actually and look at what Train's as a company, what our mission statement is. So if we go to the next slide. Our mission statement really is, how do we reduce the energy intensity of our clients? And the right approach for how we do that is different for each customer. Much more than an equipment manufacturer, we have partners, we have experts in-house that can help us with decarbonization, electrification, building automation, all these different tools that really can help our customers understand what the journey could look like for them as they try to achieve their goals. So I just wanted to do a quick level set on that, so we keep that in mind as we kind of go through some of the common goals and challenges, solutions that have become more of a trend in our industry. So as we meet with our clients, we start conversations really around, what are your goals? There are definitely more than what we have listed here, right? But these are kind of the more common ones that we've seen. Optimal environments, we're talking about both comfort and indoor air quality. There are a lot of studies that show optimizing comfort makes employees more efficient, makes students more productive. And when we're comfortable, our morale is higher. We're happy to be there. There are also different filtration and air cleaning technologies that we've talked about a little bit here that can reduce the number of sick days employees have, prevent them from bringing that sickness home, make them feel safe about going to work, and also keeping students in the classroom. Customers are also focused on reducing utility and operational spend. A common goal that we see out there is about 10% reduction in year-over-year utility spend. Some more aggressive goals that are starting to come around being carbon neutral or net zero by 2035 or 2040. Common return on investments, right? If it's under 3 years, it's kind of considered a no-brainer. If it's over 3 years, we might have a little bit more homework to do. We also have seen goals around ESG, environmental, social, and governance goals. Some of our customers are being measured or getting projects approved based on how they fit certain metrics, if it's contributing towards reducing greenhouse gas emissions, reducing waste or pollution, how it's affecting health and safety, is it improving working conditions, things like that. If we can check some of the boxes along the way when it relates to the ESG goals, it helps the project move towards the top of the list for approval. A fourth goal that's also kind of a challenge, and we've touched on it a little bit with EC and Charlie as well, is facility managers oftentimes are trying to create that roadmap on, how do I achieve my goals? Most facility managers and directors want this roadmap so they can give their leadership kind of something physically on paper or an idea of what do the next 5 to 10 years look like from a budget standpoint, from an execution standpoint. So they know the metrics, they kind of know the how-to on how they're to reach the metrics they're being measured on. So we'll circle back to that, but yeah, that bullet point goal slash challenge is really how do we get started? So with the goals in mind, we kind of move into what are the hurdles or challenges that are preventing us from hitting our targets. A big one that we're talking about today, right? Overventilation resulting in higher energy use and utility spend. We're seeing that there are many facilities that are overventilating spaces for a variety of reasons. One is because a building has been around for a long time and the use of the space within that building has just changed over time. I have a job site that was a commercial building from the 80s, normal standard office building, and today they've used those same office zone setup actually to be a clean room. So they're using the same equipment, but for a completely different application that leads them to overdrive the fans in the system and overdrive the chilled water system, which we know is just an inefficient way of achieving the goal. The pandemic, I think, also played a role in overventilating systems. Many facilities increased the number of air changes per hour in their buildings, and they never went back to the ASHRAE standards for ventilation and the minimum outdoor air conditions. Also, I think the pandemic also had a benefit in accelerating some technologies that resulted in people being able to work remotely. It became more accessible, more common across many businesses, but it had a pretty big impact on commercial real estate. Many buildings being probably in the 40 to 60% occupancy rate for commercial real estate, but we're still operating that building as if it was fully occupied. So we know we're leaving energy savings on the table, and we just got to work together to identify where those opportunities are in the building. Facility engineering teams are also understaffed. So why don't we know the answers to 1 and 2, right? The bullet points 1 and 2. It's tough because facility managers our teams are understaffed, and they're on a day-to-day basis putting out fires and just making sure that systems stay up and running and keeping tenants happy. So it's nobody's fault, no team's fault on why we can't prevent overventilating and kind of improving the controls on a day-to-day basis. Because these teams are taxed with having a lot to do. So it's just a gap we've seen in the industry and an area where we can leverage the expertise of Trane and our partners in the industry to begin to wrap our arms around where the opportunities to improve the operation, where they might be. A fourth kind of challenge out there is the facility managers come and say, hey, I have all these metrics I have to hit, but I'm not getting any money to make any improvements. So how can I get creative on how we package different projects to start to move the needle on hitting the goal? If we're just focused on replacing equipment, honestly, it can be an expensive venture and difficult to justify. So can you give me some other options to gain efficiency, but not sacrifice indoor air quality? All right, so we have our challenges. Now, how do we start to chip away with upgrading systems and gaining some traction? I focused on 3 retrofit solutions that can avoid the high capital cost of rip and replace of full units. They can increase indoor air quality, and they can help with operational savings as well. One potential solution is moving towards retrofitting 2-way valves that are pressure independent and control the specific delta T on chilled water coils within air handlers. This does a few things. One, it'll allow for precision control at the unit to deliver accurate discharge air conditions, whether it's comfort cooling or we're trying to improve better dehumidification control. Secondly, it'll reduce the amount of flow to the coil to deliver exactly what that coil was designed for. So the pump energy and the chiller system energy go down. A third benefit is we always want to be running the equipment as it's intended to be designed, or it was designed to intended to be used, right? So let's operate the coil and the air handler at its design conditions, and this is one way to help achieve that. Oftentimes what happens when we do the valve retrofit is that there's about a 25 to 40% capacity gain at the chiller plant. Specifically, we had one case where a chiller had failed. Instead of replacing the chiller, customer says, chiller fails, I need a price for a new one. We actually took a step back. We analyzed the chilled water loop, and we found that if we control the loop more efficiently, we don't need the chiller that had failed. We had enough capacity with the functioning chillers already on site, and we could actually dramatically increase the efficiency of the system by replacing the valves on the chilled water system. So it was a win for the customer because we reduced maintenance. We took a large piece of HVAC equipment out of the equation for maintenance. And it was a win for the finance team because it was a lower first cost to replace the valves rather than replace the chiller. And also the utility bills went down year over year. So it's a great first step. A second option would be to look at how do we get creative around maintenance tasks that already exist. So every air handler needs to change filters. Are there technologies that we can leverage that reduce the amount of times we have to change filters or reduce the amount of fan power required to deliver the design air? It's a huge win when we talk to facility teams because they're already understaffed and looking for help and how to reduce their daily tasks. A third option is that we can look at fan arrays for single fan belt driven motors within air handlers. We can replace those single motors with these fan arrays and eliminate the need for replacing belts, and we can improve the overall efficiency and turn down capability of the units by introducing frequency drives into the system as well. It's also a great way to gain redundancy. We have a building in Minneapolis here that is looking at this solution because they have 4 large air handlers that serve 20 floors of a high-rise building. And if they lose one of the motors within that air handler, 10 floors lose airflow, and that's just unacceptable. So they're also large built-up air handlers. It's not exactly in the budget to replace a large air handler, so they're looking for an alternative, and this is a fantastic alternative for them to accomplish the goal at a much less capital cost. A fourth option not pictured here, but I think it's worth mentioning, is let's make sure we're leveraging data in a way that helps us achieve our goals within the building automation systems. Do we retrofit entire chilled water loops with new valves, or do we have data that shows which air handlers might be our worst offenders, and we start there? It's kind of the same with filtration. Do we have data that shows some areas where the differential pressure tends to grow within the air handler a little bit faster than others? And maybe that's where we start with new filtration technology. It's just lets you leverage the automation in the system and the data to help build that roadmap for better indoor air quality and improved efficiency. All right, so we have some solutions now. How do we get started? We've mentioned the roadmap a couple times today, and there's 3 that I've seen that are kind of common out there. One, the roadmap can kind of look like an asset plan, where we look at the age of the system and build a 10-year plan out of how do we upgrade the systems on a yearly basis just to get the capital budget kind of aligned for the next 10 years. It can also look like an energy audit, where we walk through a building and start to think about where's the low-hanging fruit and build kind of energy conservation measures, a plan of action. But it also could look something like this, where we're doing an indoor air quality assessment. In some cases, we've seen if we tie indoor air quality to sustainability projects, the chances increase to get the funding. So why not look at an audit to see how are we ventilating and validating if it's in line with the ASHRAE standards. This way we can do a gut check on humidity, exhaust, supply air, filtration, all the main factors that define indoor air quality, and understand if we're achieving the goals in the most efficient way possible. The end result really is a report out for the owner to understand just a third potential roadmap option of, here's an action item plan list that helps us achieve our goals along the way. All right, so all this sounds great. We got the roadmap. We have some potential solutions. Now it's the money slide, right? Funding is likely the #1 challenge in trying to get these projects approved. There are a variety of ways that projects can get funded to meet the constraint of different budgets. We can fund projects in a way that lets the energy savings dollars work for our owners. By that, just meaning let's use the energy savings that we get year over year and put it towards the deferred maintenance, to put it towards the energy projects, and that is our payment plan to pay off the project. We can do that at energy as a service. We can do that through performance contracting. Another interesting way we can help finance projects like this is working it through what we call a service agreement funding option. It's a popular option because it actually takes the capital budget off the table, and we're moving the project into the maintenance budget. Typically less eyes on the maintenance budget. It gives also facility managers a little bit more power in controlling the scope and the vendors and who's doing the work. And then we have the traditional ways, cash purchases and some other ones that you can see there. Outside of just how are we going to get the money, we should also look at the tax incentives and rebates on our projects. We'd be doing a disservice if we only looked at the project and the cost, because oftentimes if we do a little bit more homework, we can find that tax incentives and rebates can take months or even years off the return on investment for a project, making it much more palatable for the financial folks making decisions.
Thank you, Jake. Great deep dive into ventilation and filtration. Just before we get to Q&A, I am going to kick it off to Charlie to just do a quick project spotlight, really just showcasing how these strategies that we've talked about today and technologies are making an impact in some real world projects. And then we'll go right into Q&A. I've seen some roll in throughout the presentation. So off to you, Charlie.
So we put together a couple comparison projects, and we looked at two with similar goals and similar type systems and a couple different approaches. One is just to really look at the indoor quality with no mechanical upgrades. And the other one is looking at the indoor quality, but how do we address some of the mechanical upgrades to make that system work better? So the first one is around a hospitality case study, and they were really looking at reducing costs and improving efficiency. Coming out of post-COVID, it was a challenge for them to have the rooms full and all of that, and they were looking ways to absolutely save the money today. So again, we were looking at operational expenses and energy spend and aligning with some of the carbon footprint reduction mandates. The challenges, they had an old system into the world of that, and there were signs of some deferred maintenance, as well as really limited on the data that we could capture off the system. So we looked at two measures. We looked at the ASHRAE 241 assessment with Poppy, and then we looked at the low pressure filter retrofit into the system. And again, we're able to get energy savings, operational savings, and sustainability with those two options. Doing the initial for the conference center, the ASHRAE 241 assessment identified $117,000 a year more in savings, and with some just quick changes to the system of what they had, the payback was actually 1 week. When we looked at the filter retrofit, a little more capital intensive on it, but still really helped the operational team, and we identified roughly $17,000 worth of savings and under a 2-year payback. So it definitely checked all the boxes and achieved the goal of the owner to go ahead and get that savings reduction right away. What we were missing, though, as we went through it, with having just that as strategy and not considering the mechanical on there, we were really looking at what other things could we have gotten done in there. Were there some small projects that we could strategically reinvest some of those savings in, since it was so far below what the threshold of payback was? Are we really able to optimize? And can we look at it from a high performance building standpoint? If we still have all the right tools in the toolbox, but the system's not able to maintain those high performance systems, then we probably left a little bit of the project on the table of what we could have achieved. Second one is really around an office building. Again, looking at corporate carbon footprint reductions, energy savings to fund the project, threshold of operational costs, and again, look at some of the deferred maintenance. What are some of the small things we can do in order to have better visibility and control into it? And again, the building is over 20 years old, and so is the equipment. So we saw a lot of inefficiency between the filter specification and really about controlling the system. So when we brought this one together, we started out with the ASHRAE 241 assessment with Poppy. We looked at the filter strategy and what we were doing there. And then we looked at some of the system upgrades and really didn't look at big things, but again, some things around the delta P valves, really more control strategies, more programming into the system for better visibility. Financially, we came out pretty darn good, around $90,000 worth of savings, a 13-week payback from optimizing the ventilation from a ventilation standpoint. The filter retrofit was delivered a lot of savings in the world of it, reduced the amount of operation time, and the payback was in 18 months. Collectively, we had a very strong ROI. So while we were there, we looked at around the air handling units and things that we could do to optimize into that. And that was actually going to be a little more that was over the 3-year threshold at a little over 400,000. But when we combined it together in a ventilation optimization, we were able to capture over $150,000 a year in savings. And to meet that threshold of 3 years, we came in just underneath it in order to get those things. So a couple approaches, again, optimize the ventilation. It's where we like to start, gives us the land that we have to work with. And then, but again, as we're getting down to the end, there's nothing wrong with taking a look from a system standpoint. And I think that's the value of everybody on this call today, of the panels between Jake and EC. You know, we come together and we help bring that data together, and we make collective decisions to help benefit our clients along the way and do what's right for their buildings. Key takeaways: implementing comprehensive ASHRAE 241 assessments, understanding your ventilation, looking at your filter strategies, what kind of upgrades can support those improvements along the way. Really have a way to deliver healthy buildings, reduce our energy and our operational savings in the process.
Thank you, all three of you, for your great presentations. They were all super insightful, and I'm sure all of our attendees agree. There are some questions that have run through, as I've mentioned, in our Q&A section, questions specifically for our panelists. ECA, one came in from Chris as you were presenting. Are you often dealing with customers who are worried about what their IAQ readings may find, because then that would force them into finding funding for the solution? And if that is the case, how are you overcoming that obstacle at Poppy?
Yeah, it's a really good question, and I would have a very different answer 3 years ago than I do today. Just to be clear, what we're doing at Poppy is not traditional IAQ, and typically what we do when we're going through and doing the first assessment of a building is we're providing materials to the owner, building owner, and operators to provide to the tenants about what we're doing. But typically in there, we don't talk about IAQ. We talk about, you know, what we're doing to measure ventilation efficiency and effectiveness, and that is typically, you know, they might get a question or two about, will this disrupt, you know, my workday, which the answer is always no, and we go on from there. So that hasn't been a concern that we've come across. Now I know Charlie and Jake probably with more comprehensive projects with lots of more moving parts may have come across this too. So I'm not. I would love to hear what either of them would have to say.
Jake, Charlie, any insights there?
I really haven't. Again, that's some people don't want to know what's in their building. We get that question a lot. So I want to make sure it's healthy. But if there's something in there that isn't, I don't want to know what it is. And so I think our processes and what we do, we're not needling down into, did you see the size of that particulate that could be whatever? So it's really around, we want to help manage expectations, and I think we bring that comfort in the building. It's really around the story of, we want to provide a healthy, clean environment for you and see where we can bring the savings on top of it.
Perfect. Thank you so much, Charlie. Jake, I did see one come in when you were presenting, also from Olga. She missed part of the presentation. Is wondering, does your AI control RTUs?
So yeah, we are seeing a lot of movement in the autonomous control space right now. I would say, so yes, the quick answer is yes. The ideal solution right now for our autonomous control is probably based around rooftop units and VAV boxes. But it's really, to answer that question fully, I'd want to know a little bit more on what she's curious about, and maybe do a deeper dive on the side with her if possible.
Okay, cool. I will let her know that, and you guys can do a follow-up after our webinar. Did see one more just run through here as well. How are you, and I'll address this to all of our panelists, how are you overcoming customers' hesitancy to reduce ventilation air rates in search of energy savings?
I'll start with just a simple comment. True to our heart, and I'm sure everybody on this panel and hopefully everybody in the industry, you never go below code. But code is our guide, and then currently ASHRAE 241 is above code. So buildings who are also adjusting to 241 are doing even more than what's required in local building codes today, though it is starting to be adopted in certain geographies as code itself. You would, nothing, no recommendation I'm sure any of us would ever make would take it below code and take it to a place that a customer would be concerned, or an occupant.
I think overall, there's a lot around that overventilation, and we see a lot of things today saying, all right, we exceed the minimum requirement. So a lot of times, there is a lot of space when we look at, our safety factors within our designs. But to EC, again, we never want to save money to jeopardize the health and well-being of our people within the buildings. That's just a core value as we approach it.
Maybe
completely agree.
Sorry.
Yeah,
just one of the questions that sometimes comes with this is this going to affect comfort? And no. So what we're doing, what the focus of we're measuring is outdoor air filtration and all the filtration methods within the building. And so we've never had a complaint of heating and cooling feeling differently to individual tenants or humidity based on the type of work that we're focused on, or that gets measured through us. But that is usually a question that comes sort of hand in hand.
Jake?
Awesome.
No, I was to say I completely agree. Health and safety is paramount. We want to make sure comfort is and set points and things like that we're always optimizing the system to hit the metric ultimately of what the zone needs and what the requirements are. So when we talk about recommissioning, just over time, systems can get sloppy. We're just recommissioning back to the standard and back to what the design conditions were, never going lower.
Yeah.
Awesome. Thank you all. We have one more question, or two of them actually, that have come in. Whenever I've approached a customer with a package solution like what's being presented, upfront cost has always been an issue. Even if there are rebates or subsidies, customers aren't interested in adding to their current budget. What has been the most effective way for you all panelists to be able to really get your foot in the door?
From a project development standpoint, I get brought in early onto those things. And again, from a collaborative approach, if we look at all the teams available on this call, whether it be the Blade or the Poppy, the Train, the Keynotion, we do a lot of that heavy lifting up front in that initial assessment so that we can keep it low. I've gone in and done just a single zone test to say, here, look what we're seeing, and really keeping that low. And I think we started out from there. But a lot of the things we're talking about today, the payback is so quick and the financial benefits out there, we shouldn't be adding to the spend of the budget when it's all said and done. This should be a cash flow positive endeavor for all of our clients along the way. So I think it's just really walking through a process, understanding how to develop, what's going to happen each step of the way, and keeping that client, in current with what we're doing and how we're doing it.
I'll just go ahead, Jake.
Yeah. I think it's, what bucket of money are we trying to go after too? If we're talking about capital plan money or maintenance budgets, right? I have had a lot of success moving projects from capital budget to maintenance budget and being able to pay for projects through what we call a service agreement. The other thing that I think Charlie's alluding to too, right, is like the money is it's already being spent. It's just being spent in a different bucket of money in energy. So let's try and transfer those dollars over. If we can have a good message around how we're transferring those dollars that are already being spent and they can work better for you by paying for these projects or deferred maintenance, that's a strong message on how we try and get our foot in the door.
Maybe I'll just add, I appreciate Cody asking this question, and really our our purpose in introducing, a puppy-based ESCO model, or, the world's simplest ESCO model, hopefully, this year for our customers is for the buildings we have a good sense are high energy savers. We actually, the customer doesn't pay a penny until they start getting savings from us. So we, and then we split it, like I mentioned earlier in the presentation. So not every building qualifies, not every building, sort of has that as an option, but that is a really quick, fast, easy way to get folks to say yes and get going on the types of buildings that a lot of the time we're working with in the office and the retail and public venue space. No dollars out of pocket.
Amazing. Thank you, guys. With the increasing pressure to balance IAQ improvements with energy efficiency, how do you see the role of advanced filtration materials, particularly bio-based or naturally electrostatic media, shaping the future of sustainable building performance? What are the biggest hurdles to wider adoption of these next generation filtration technologies? And how can manufacturers, building operators, and regulators collaborate to accelerate their implementation?
That's a long one, Ava. I think, the education to beginning with into the world of it, and when you bring something new into it, it becomes an education model. So I think as we go through with building owners that have those questions about any of the technologies and things that we do, we start out with that education. As we look at the different filter medias and different technologies out there, I think people like the good people at Blade are really looking in the future to help us guide and find those other alternatives. We had a small community that was considering the impact of switching to electromagnetic in their community. And so we calculated that based upon everybody throwing away their air filters, that added 14 tons of waste to the landfill every year. We looked at different medias that we could put in there and different strategies. We were going to reduce that by 95%. So I think, again, each system, there's some systems that may not be a good fit for electromagnetic in that. I think that there's a couple environments I would say, but the majority of all that we have, it's a pretty good fit, and it's really a sustainable option for us to consider.
Amazing. Do you ever get the question from prospects, is the new system louder? We already get complaints that it is louder in our office from our air system. So I think, Jake, this one might be for you, unless this could be a Poppy question as well.
Yeah, so noise is definitely something, when a customer gets in tune to hearing it never goes away, right? So I think, though, when you're going to low pressure filtration, you can turn the fan down, which inherently will lead to noise reduction. When you're going to fan arrays, you kind of have the same effect, where you're going from a single constant volume supply air fan to now you have a fan array where you can get drastic turn down on those fans. Maybe you're operating one fan at a very low speed. So again, noise reduction. So no, it's a lot of times when we're doing these retrofits, the noise will either be the same or less.
Perfect. Thank you so much, Jake. Last question that I've seen roll through, and then we're going to wrap up for today. Sorry for going 2 minutes over, guys. We have a very engaged group, so that's really awesome, though. What's the best resource to refer to for fresh air ventilation rate per person in various buildings and relevant information and standards without actually needing to contact an engineer?
It's an EC and a Jake.
I mean, I would direct folks to the ASHRAE site to in 241, there's a table 5.1, which is the equivalent clean air required per person based on the space type use. So an office less than a gym, as an example. But those are generally, again, above and beyond code. I don't know if I'd ever say 62.1 is something that you would read without an engineer, but I'll hand that over to Jake as the engineer.
No, no, I would agree. And even as Train, right, we have a lot of engineers in-house, but we don't stamp drawings or do anything like that. So we also engage outside help when it comes to those things, to make sure we're doing all the right things, and have engineering firms and partners in the areas to help us along the way.
I think for a lot of
Okay.
building owners, they have resources like all of us, or you can reach out to us as well. So that's an easy one. Just ask us a question and we're here to help.
Thanks, Charlie. Well, with that, I don't want to take any more of anyone's time because we are over. So I'm going to wrap up today's discussion and session. I want to again extend a huge thank you to our incredible panelists, Charlie, EC, and Jake. If there's one main takeaway from today's session, it's that really energy efficiency and air quality aren't competing priorities. They can go hand in hand, especially with the right technologies and strategies. These are very possible without overburdening your systems. If you do have any additional questions that we weren't able to address in this Q&A period, please feel free to just reach out to our team directly, info@bladeair.com, and I will get you in touch with the right person that you need to speak with accordingly. As I mentioned also, this webinar is being recorded and will be available soon along with the deck. And let's continue this conversation. Please connect with all of us on LinkedIn, stay engaged and keep in touch with us. Thank you all for joining today, and we look forward to seeing you guys again soon. Have a good day, everyone.
Thank you, Ava.
Thanks,
Yeah,
Eva.
thank you.
Thanks, everyone.
See you.